Good morning everyone. In today's video we will see how we can build any electronic circuit on Circuit Lab simulator. Today we will see how we can build a non-inverting amplifier of an op-amp using Circuit Lab simulator. So for this you just have to open circuitlab.com. It is an online simulator. You don't need to download it. You can just use it in online mode. So first we will see how we can build a circuit using Circuit Lab and from where we can take any component. So first let's start. So you have to open this circuitlab.com. This is a simulator. This is available free of cost at this time for personal use. So first we will start with this component. First suppose we have to connect an op-amp. So we will take op-amp from here. There are two op-amp available. One is without voltage rail and one is with voltage rail. If you want to change the value of VCC and VE, you will choose this op-amp with voltage rail, and if you don't want to change, then you will take this simple op-amp. So we have taken this simple op-amp. Now suppose you want to connect some resistor. So you will search resistors from here. So you can choose resistor from here and you can move this resistor by just pressing R. You can rotate this. So suppose this is resistor, and how to make connection? Just take it and connect it. How to change value of this resistor? Just double click on it and you can change its name, its value. Now for applying any voltage, you need voltage function generator. So you can search from here. You will write voltage function generator. So we have chosen this voltage function generator. So this is our voltage function generator. You just can connect it like this, and by double clicking on it, you can change its amplitude, its frequency, or whatever. If you want to change its state, whatever you want to do, you can do after double clicking. In the same way, we can connect some more resistor. Now for seeing output, here we have node. You can just search here, this is node, and this is our node. So suppose you want to check the value of input, so you will connect this node here. If you want to check value of output, just copy it and paste. Wait a minute. Just copy it and then paste it and just connect here. You can change the name of node by just double clicking on it. Suppose I am saying node 2, or I can write it like the output. So it is our choice. Then you can complete the circuit as per your requirement. So in this way we can create any circuit on this Circuit Lab. You can use op-amp, you can create some another circuit like an analog electronics, any oscillator. So every circuit can be created in this Circuit Lab simulator. So before starting simulation of a circuit, we will go to the slide. There we will see how to build an operational amplifier in non-inverting configuration, and then we will build that same circuit in Circuit Lab, and then we will simulate. Cut. Now come to our slide. This is our op-amp based non-inverting start. So now coming to the slide, it is our op-amp based non-inverting amplifier. So in op-amp based non-inverting amplifier, you know that if it is a non-inverting amplifier, so we will apply input at the non-inverting terminal. So it is our non-inverting terminal, so we have connected an input source, that is Vin. We have connected a feedback resistor from output to our inverting terminal. So that means some part of output will be fed back to your input, that will be on inverting terminal with the help of this feedback resistance R2. R1 is my input resistance, and this R1 and R2 will work as an voltage divider circuit that will feed back some part of Vout at this V2. And you know that the output of a non-inverting amplifier V0 is equals to V in 1 plus R2 upon R1, where R2 is my feedback resistance and R1 is my input resistance, and V the value of voltage whatever we have applied. So you can get the output, and you know that in case of non-inverting amplifier, output will always in phase with our input. So now we will build this circuit on our Circuit Lab simulator, and then we will simulate. So we have built this non-inverting amplifier on our Circuit Lab simulator. So here we have connected our feedback resistor, that is R2, and chosen its value as 9 kilo ohm, and input resistance R1 taken its value as 1 kilo ohm, and voltage source, that is V1, and we have taken its value as amplitude as 1 volt and frequency as 1000 Hz, that is 1 kilo Hz. Okay, so we have connected the circuit just like we have explained in starting of this video. So there we have used two nodes, one for the input and other for the output. So we have completely built this circuit. Now we have to simulate this circuit. So to simulate this circuit, we have to just press this simulate. Now you have multiple options available here. You can have a DC sweep, runtime domain simulation, and frequency domain simulation. So first we will perform the time domain simulation because we want to see the time domain behavior of this non-inverting amplifier. So here start time is 0, stop time is 4 millisecond. That means this process will run up to 4 millisecond. You can see that our sine waves of 1 kilohertz, that means this time period is 1 millisecond. And so there will be 4 cycles. So we will press this run time domain simulation. So as we press run time domain simulation, you can see that here it is shown as our input. This is our input and this is our output. As we chosen as our time period at 4 milliseconds, so here 4 cycles it is showing because our one cycle is of 1 millisecond as frequency is 1 kilohertz. So you can see that when your input reaches as 998 millivolt, then your output is around 9.978. That means you can say that it is multiplying by around 10. Our gain is coming as 10. Now we can check in theory that we are getting same gain or not. We will check it also if we are getting same gain in theory or not, because from this diagram we are seeing that around 999.3 millivolt we are getting an output of 9.991. That is approximately equals to 10 times. That means our output is 10 times of our input. And you can see that as we told you in theory that in non-inverting amplifier output have same phase with the input. So you can clearly see that the output phase is similar to your input phase. To check the frequency response of amplifier, we can also do it frequency domain simulation. So again we will press this simulation and we will go to frequency domain and we will run frequency domain simulation. So you can clearly see that this is this frequency domain simulation. You know that what is meaning of frequency analysis of op-amp? Frequency analysis show us ki how much gain is constant during a particular frequency interval. So you can see that from 1 Hz to around your 100 kilohertz. From 1 Hz to 100 kilohertz, the gain of the amplifier is constant. There is no change in the gain. That means if we want to create a signal, if we want to amplify a signal using this type of amplifier, so our chosen frequency range should be range from this 0.1 to from where it is around 100 kilohertz. So a signal having a frequency from 0 to 100 kilohertz will have a constant voltage gain through this circuit. So in this way we can simulate any circuit in circuit lab. Now come to theory and we will see that it is okay or not. What we have performed here, it is also in theory or not. So go to the slide. Here you see that V out is equals to V in into 1 plus R2 upon R1. And you know that what value we have taken for R2? It is 9. And what value we have taken for R1? It is 1. So if we will put this value here, suppose I am putting this value here. So what I will get? I will get V in is 1 volt. You know that we have taken it as 1 volt. 1 plus R2 is 9 divided by 1. And if you will solve it, you will get it is around 10 volt. So same thing we are getting. If our input is 1 volt, then output should be equal to 10 volt. And same thing we get in our simulation. When our, we can check again. It's our time domain simulation. As we mentioned, when your input is around 965 millivolt, your output is around 9.66 volt. That is 10 times of your input. So we can see that in simulation it is perfectly matching with their theory. So this is about the op-amp based non-inverting ampli.